Welcome to Mass Foundations. Today we will start a series of lecture based on the topic mechanics of deformable bodies. It is also called as theory of elasticity. Theory of elasticity. Okay, this is a very lengthy chapter, and it is based on the micro level sciences, that how deep you can understand right from an atom to the mega structures. The theory of elasticity works. It has many sections. First section will and study about the introduction of this theory of elasticity. Okay, we shall start. Based In order to proceed to the introduction, let us assume that for a making of any structure, any machine, any civil engineering structure, any civil structure, any other type of structure, any other type of structure, or to develop a mobile phone or etc. Any other. First, you need an objective. First, you need an objective. What is the objective? That what you want to make. You want to make a mobile phone. You want to make a machine. You want to make a building, etc. I don't know. You first need an objective. What you want to make. Then if the objective is decided, you approach to a function or a natural system. Natural system maybe look like this. It's a natural system. It's a natural system. Natural system is what, sir? It's a function. Function is what? Function means a type of machine. You give input, it will give you output. Okay, you provided input, it will give you output. How input output? For example, x square is a function. I will put one value. I will substitute the value of x. I will get one. I will get one. If I will substitute the value of 2, I will get 2 square, that is 4. If I take the value of 3, I will get 3 square, that is 9. So what is the natural system? It is a function. Functions means what? You will get, you provide input, you will get output. And major designers know the output. So they choose a function such that uh, how input is provided to get the designer's output, to get your idea about the output. So this is a natural system. Natural system you take as an environment, anything you take under the natural system, or it should be in a category of function. Function, already you know what is that. You provide input, it will give you output. You provide input, it will give you output. So this is a natural system. And when once you decided the natural system, you idealized that system. Idealize means a constant way. For example, this is, you idealized that system. You convert the system into an idealized system. Idealized system is what? And how to convert this idealized system? This natural system is converted into this idealized system by certain assumptions. By certain assumptions. By certain assumptions. By certain theories, by certain assumptions, your natural systems is converted into your idealized system by certain assumptions. In assumptions is what, such as for example, I will give you some example about the assumption is, in the strength of materials or the mechanics of materials chapter, you studied an assumption that plane section remains plane even after bending. This is an assumption. However, the environment is the environment. You have studied this plane section even after this section sways. This plane in the it becomes a plane even after when it is bent. So you convert this natural system into an idealized system by certain assumptions. Why idealize the system? In this idealized system, you can apply your rules to get your sustained outputs. Why this flowchart is there? You want to get the sustained outputs. You want to get the output of your choice, and you want to determine what type of input you are introducing to the system. So what you first step is the objective. Second step is a natural system or function that you want to build. You have selected a natural system. You idealize the system by taking the certain assumptions. Then after the idealization, you convert this idealized system into a mathematical model. What is this? This is a mathematical model. We convert this whole idealized system into a mathematical model. What is a mathematical model? You convert this system into equations, any type of equation, whether it is a linear differential equation, nonlinear differential equation, partial differential equation, any type of equation. You convert this idealized system into an equation. Why this is done means, in order to find the next step, that is what, when you convert this mathematical model and you take the solution of this model, you take the solution. Once you convert this idealized system into equations, any equation, linear differential equation, nonlinear differential equation, partial differential equation, any type of equation, etc., then solution of this equation. Once you find out the solution, you have achieved. And the steps will not over when the solution is done. When the solution is done, you will find that how input is applied to get a sustained output. For example, your output is the building. Take an example, your output is building. So what laws you require to construct a building from an open land to a mega structure. Okay, what laws are required, that you mean by this procedure. And when the solution will come, you will find the solution applicability. You will find the applicability of solution. Applicability of solution. Whether the solution exists for this, whether this solution based this, you find the applicability of solution. Whether this type of solution exists for your this natural system, for your this idealized system. Because we can't live in this idealized system. We are in the state of natural system, that things go according to the system, environment plays according to a system. It can't go by idealized system. We assume certain assumption to convert this natural system into an idealized system. Why will do means, because in this natural system you can't determine the inputs to get the outputs are different. To get that type of output only, you have to determine the inputs. So this is the flow chart. This is the star number one. Okay. After knowing that what is the flow chart of the procedure of constructing base in discovering a mobile, etc., we'll go for the what is the classification of mechanics. We'll study what is the classification of this word mechanics. Mechanics is classified into two types, where often you will study these two types. Already studied these two types as mechanics of rigid bodies, mechanics of deformable bodies, mechanics of deformable bodies. Your studies in mechanics of rigid bodies are, you assume here, what is the assumption is there? The body is rigid. The body is rigid. Rigid means what? At the net force acting on the body is what? Zero. That is, no displacement the body is creates. In this deformable bodies, you will learn again two types. This, the bodies which are deformable. This bodies are deformable. Bodies are deformable. In this mechanics of deformable bodies, again there are two types. You will study solid mechanics you will study fluid mechanics. Solid mechanics and fluid mechanics. Fluid mechanics, you know that. Fluid mechanics, you already know. It relates to the fluids. Here we are main concentrating about the word called solid mechanics. Again, in the solid mechanics, again there are types as elastics, elastics, viscoplastic, elastics, viscoplastics, and others are there, but we'll not consider about that. We'll only concentrate upon elastics. Elastics means what? Which regains its original dimensions up to a certain point. For example, this is the nature of steel. You can say here is something. It go down and here. This is up to this point where word elastic is used because it regains its original dimension when the load is removed. Okay, we'll classify this elastics again into two types: linear elastic, linear elastic, non-linear elastic. For example, the elastics are the materials. These materials has you can analyze this material in two ways. Either you can analyze linearly or you can analyze non-linear. For example, linear means what means what means. For example, this is a graph of the steel. This is a strain here. This is stress here. This is stress. This is strain. This is a steel. Steel linearly it varies up to a certain point. Then up and down will come and like this come. Here is the breaking point. Up to this, steel regain its original dimension on the removal of the load. So this point on this, okay, this is the thing where linear will come. Stress strain over here. This is what? This is the linear part. This is what? The linear part. This is what? Non-linear part. This is what? Non-linear part. This is linear part. So two types of analysis are there. This is the linear part up to this. This is the non-linear part. Will not will later we'll study about the non-linear parts. Later we'll study about non-linear part. Later we'll go analysis for the linear part. Again some classic analysis. Again some in the linear analysis. Again you will see again two things. Whether it is static analysis, statics and dynamics. Again we'll study the dynamics again in the later part. We'll move forward from statics. Again, while analyzing the body which is linear and which is elastic and which comes under solid mechanics, we'll analyze the statics in two situations. Again, in two situations. We'll use the laws of equilibrium or we'll use the law of stability or stability purposes. We'll use equilibrium or stability. And when we will use equilibrium, when we will use stability, we will see in the later parts. And both are considered to some extent. Both are considered to some extent. Okay, so in this theory of elasticity, today we will concentrate upon the mechanics of deformable bodies. And in this, we'll see the solid mechanics. In this solid mechanics, we'll concentrate only on the materials which are elastic, which regains its original dimensions up to certain points. Again, in this elastic, we'll only see about linear elasticity or the materials which varies linearly. So we will study here. For example, this is the graph of steel. We'll study here only. We will not go beyond this. This point is what? Limit of proportionality or elastic limit, where up to this Hooke's law is valid. So we will analyze here only, this situation only. What happens in this linearly? In that, again we will analyze this about statics part. In linear analytic, we'll study elastic. We'll not study the dynamics here. Again, from that elastic, we'll use these two laws. that is equilibrium and stability. We will see this how equilibrium and stability is used to convert to analyze the things. We will see. Okay, after studying about the flowchart of the things and also the classification of mechanics, we will move to the fundamental idea of relating something with others or relating the things. That is the mathematical fundamental idea is called as force. So what is the force? Force is a mathematical idea, or it is a more general mathematical idea to relate the things. What is this? A more general, more general mathematical idea, more general mathematical idea to relate things, to relate different things under some conditions. I will classify this force into two parts, two types, as you have studied about internal force and external force. What do you mean by the internal force? For example, consider a truss. Consider this type of truss. You are given here the supports. Consider this truss. If you apply any load here, and as far as the assumption of the truss says that the load applied only at the joint, so the truss will resist this load only in terms of reducing the internal axial forces in its members. These forces are the internal forces. These forces are internal forces. And these internal forces may be in the trusses, maybe it may be a tension force, it may be a compression force. Okay? Then what will be the external force? External force which acts on the body. For example, in this system, it is the external force. This is what? External force. I want to relate this external force, this stress system, this support. So I will take the advantage of the topic called force, of the word or the concept called force. In the external force, again I will classify this external force into two types. Distributed forces. Distributed forces and discrete forces. Distributed forces means these are the forces which are distributed. How much? What is the meaning of the distribution? For example, this is the area. For example, I have distributed something force, something load on this area. Load on this whole area, I have something. I have distributed the load. So this on this area, I have distributed this load on all over this entire area. So this is the meaning called distributed. Discrete means different. For example, consider this area. I have considered this is as a beam. You can consider. For example, consider this beam. I have applied the load here. Then I will apply the load here. I have not distributed. Then I apply the load here. I have not distributed these loads. I have just applied the loads. So we'll again see the later parts of distributed as how the distribution of the force is there in T types. I can distribute this in a line, in some area, in some volume. Line means, for example, consider a beam, consider a single dimension beam. I have distributed some forces or some loads in a continuous line. It is called as a line, simple. Area, forces which acts on the surface. Force which acts on surface. Forces acts on surface. For example, friction. Friction is acts on the surface. For example, this is a road. You are walking on this road. Your steps will create a friction. This is surface friction which acts and it acts on the surface. Means this surface force, it's a surface. So this surface force requires body in contact, requires the contact, bodies in contact, or considered a volume force. Volume force means the force which acts on whole body, or acts on whole body. You can say it's a line, you can say a one dimensional surface, you can say a two dimensional volume, you can say whole three dimensional. So it's act on whole body. For example, the gravitational force. For example, take a gravitational force. How? For example, consider this block which has a weight of W. So gravitational force means it acts through the center of gravity and act downwards. Here, if the particle is A, if this particle also experiencing the gravitational force. Here some particles are there. This particle also experiences gravitational force. Through this gravitational force acts through on the entire body. So another field you can say a magnetic force. This is also a volume force, or volume force is also called as body force. Volume force also called as body force. Magnetic force you can take inertial force. Inertial force, you require resistance, or inertia is required, and inertia acts on the body. Inertia is what? A resistance. For example, how to explain this inertia means, for example, if you are moving like this and suddenly some turn comes like this, you will turn in this way. While turning, some resistance is developed. So that resistance is what? That inertial force. This inertial force acts on your whole body and not let the body to turn. So when you turn it, you require some more energy than turning rather than not turning. So that is called as the inertial force. It's a body force. Okay. After studying about the concept of flowchart, classification of mechanics, again classification of the force, will come to a more general idea, which relates these four quantities. We'll write these first four quantities, that is force, we'll write displacement, we'll write stress, we'll write strain. I already explained you what is the force. It's just a mathematical idea to uh, express different or the situation, or to relate the things, to relate the materials, to relate the actions of to action and reactions. Okay. Displacement, you know what is the meaning of the displacement? Displacement is what? For example, consider a simply supported beam. This simply supported beam has been deflected like this. So what is this? This is called displacement. So you will learn in more general about displacement in later classes, that what displacement is actually is. And you know what is the meaning of stress. I will discuss the brief definition of stress in detail. Just you know that what you mean by the stress. Okay, it's generally force by area. How does the definition transform from force by area to the state of stress at a point? And we'll see what you mean by the strains. And you know that all. What is the simple strain means change in dimension by original dimension. Okay, what do you mean by the stress means actually it's a force by area. And it's a childish definition. We'll learn in more general what it is. So we'll see this all four: force, stress, displacement, and strain. Before we'll see this definition, and how force and stress are related. We will see how these are related. These are interconnected. Force and stress are interconnected. The basis of this interconnection is equilibrium. The basis of this interconnection is the equilibrium. Equilibrium connects the force as well as stress by certain equation. Equilibrium will connect this force and stress. For example, you take equilibrium to constitute these forces. Okay, you will apply some equilibrium condition that the force across any horizontal components are zero when you consider equilibrium. Force along all the vertical components are zero. Force the moments at any point when the body is in equilibrium, the moments at any point must be attendance to zero. Okay, the equilibrium, and we'll discuss more in detail about how equilibrium relates to this force and how the stress strains are related. Stress strain also collinearly. If you these are related by constitutive relation. Constitutive relation. Constitutive relation. Stress and strains are related by constitutive relation. What is the meaning of the constitutive relation means? If you know the value of stress, you can determine strain. If you know the value of strain, you can determine stress, etc. So the relation which connects stress and strain is the constitutive relation. Then we will discuss about the strain displacement. How does the strain also same and displacement also same. Displacement has a unit, strain does not have a unit. And how these two are interconnected? These two, for example, strain is connected to the displacement. If you know the value of strain, you can determine the value of displacement by compatibility equation. Compatibility equation. And if you know the value of displacement, you can find strain by strain displacement relation. Strain displacement relation. And we will discuss in detail about what is compatibility equation, what is strain displacement equation. It's a brief idea I'm giving. What is constitutive relation, what is equilibrium relation, and finally force and displacement there is a major suspense, and more general way it's not there to access the force and displacement, but on basis upon these three parts you can relate the force and displacement. In the later chapter will develop one concept which connects this force and displacement by an interconnection way. And before this, you will understand something that force, okay, before this, you will understand something that force, stress, strain, and displacement. This all four, one, two, three, four. This all four words are the concepts. One, two, three, four are concepts. These are what? The concepts. And this equilibrium equation and this equilibrium equation 1, constitutive relation 2, compatibility equation 3, strain displacement equation 4, and we'll develop one equation which connects force and displacement as 1, 2, 3, 4. These four are equations. These are not concepts, these are equations. This equation will connect these concepts. This equation will connect this concept. And we will see that how this equation will connect these concepts in the later parts. Thank you. uh, Before going, in order to complete analysis of all this theory of elasticity, please see the later chapters. And if you have any doubt, do comment below. And Jones and watch the complete video to analyze the structure or to analyze the theory of elasticity in detail. Thank you.